Okay, so the material we cover, I think I just figured out where that echo is. That's only bugging me. Okay, the material that we cover at the beginning, the first, 6, 7 problems are not on this test. Okay, so we're starting to work towards the next exam. Alrighty, and then we're also going to review problems on the test. Okay, everyone has their funny little things. I have a dried out package of wipes that makes for a perfect, like it's my little security thing. I have to use that. Okay, sorry. Okay, anyway, new material. Now I need you to look at number 1 and number 3. Okay, they are equations to solve, but they are very, very different. 1 and 2 are very, very, very different from number 3. So the question is, where is the variable? Okay, notice number 1, the variable is the exponent. So this is an exponential. Okay, because the variable is an exponent. Exponential. My horrible handwriting. We're actually going to do number 3 first. This is, now it's kind of called a few different things. This is a power function. Okay, so examples of power functions. X squared would be a power function, right? So x squared would be a power function. How would I solve the equation x squared equals 25? How do I undo a power of 2? Root, right? Square root. I would take the root of both sides. Now notice there's nothing right here, but that is implied. There's really an invisible 2. Okay, invisible 2. So I would take the square root of both sides. I would get 2 answers plus or minus 5. See how that means 2 answers plus or minus. You read that x is equal to plus or minus 5. Okay, so if it's a power function, if the base is your variable and you know the exponent, you can undo that exponent with root. Okay, so we're going to do 1 and 2 in a minute. Let's do 3. Okay, so how do I undo a 5th power? Careful. You undo squared with square root. So you undo 5th, and I can't see I'm assuming you guys can all hear me. Can you all hear me? I hope so, because I just said a whole bunch of stuff. Okay, can someone say yes that you hear me? I'm getting nervous. Oh, yay, thank you. Okay, to undo square power or power of 2. Okay, to undo a squared function, we do square root. To undo a 5th power, we do root, right? Right? We're here to do a root. Okay, so this is what we're going to do. But we're not going to do the square root of both sides. We're going to do the 5th root of both sides. There used to be more. Okay. Now, the 5th root for today, we're going to get a decimal. We're usually not going to do decimals, but we're going to talk about how to take the 5th root of a number later. So on the calculator, everyone practice with the calculator. Okay. Now, there's different ways to do this on the calculator, but to be honest, the fifth root. Okay, let's do this one more way and then you'll see why this works. This is the easiest way to do it on the calculator. The fifth root is the same as raising it to the 1/5 power. Yeah. Can you see that right here, raising it to the 1/5 power is going to make that exponent of 5 disappear because the 5 on top is going to cancel the 5 on the bottom. Yeah, that's a little tricky, but do we see that? So instead of the fifth root, I'm going to raise it to the 1/5 power. And I'm going to raise this side to the 1/5 power. And it turns out to be a little easier on the calculator. Okay. So 50 to the 1/5 power. So I'm going 50 to the 1/5. Do that. Hold on. Okay, which brings up a point. When you come in to take the next test, if you have not been coming in for review sessions in person, we may need to discuss the calculator. Okay, so 50 to the 1/5, 50 to the parentheses 1 divided by 5 parentheses, you should get 2.1867. Yeah. And then I would need to tell you what to round that to. Let's go ahead and round that to the hundredths. Well, I would need to tell you because I can't tell you it's the same every time, but you would ask, like, where do you want me to round? You didn't tell us where to round. Okay. Okay, so that is solving a power function. If I have the fifth power, I'm going to take the fifth root, but instead of taking the fifth root, I'm going to raise it to the 1/5 power, which is kind of a little shortcut. Okay, now, number one, what root should I take? I don't know because I don't know the power. Can you see that we need a different tool? I don't know what root to take because this is an exponential. So I'm stuck. I can't just use a power. Okay, now I want to direct your attention to the notes. Now, I realize I excuse the notes if you don't do them. Okay, but I do highly recommend them. And my mouse is not plugged in. But I'm just a mess. And sometimes when I plug the mouse in, I turn the computer off because it's really cool that way. Oh my gosh. I will never again plug in that mouse. Okay. So this is not the way it was going to work in my brain. Okay, in the notes, you see this equation, okay? Highly recommend looking at the video for this in the notes. It won't split. Okay, so this is not how I envisioned this was going to work. I'm trying something new. So in the notes, what do you notice about this exponential equation? You are solving an exponential equation. Okay, so we notice that they have the same base. Yeah. So in the notes, this video, we say if the base is the same, then, okay, so go ahead and write this down because this is gonna disappear in a second because I can't plug my mouse in anymore. Okay, if the base is the same, then anyone do the notes? Anyone have a guess of what my next? No, that's logarithms. I think you're thinking logarithms. Okay, if the base is the same, then we bring down the exponents. And I can't do that. I just have to make this disappear. Then, boy, hello. Oh no. Something's not good. Okay. Anyway, you're gonna have to watch the video. There we go. Ah, found it. Okay. If the base is the same, then the exponents are the same. And if the exponents are the same, we can bring down the base, the exponents, and you'll notice the bases disappear and the exponents come down. Okay, so in the notes, when the bases are the same, then the exponents are the same. The base disappears and we bring down the exponents. Okay, so highly recommend watching that video for the notes because it's good to see other people besides me. Okay, let's get back. Let's actually get this done. Okay. So we have, but wait, the bases are not the same. Okay, so let's look at the back of the chart of factors. The back of the chart of factors has the table of powers. Okay, so, and you would have this when you took the test. Notice that 36 is 6 squared and 216 is 6 cubed, right? It says right here that it's cubed. Yeah. So in the table of powers, we see that 36 is 6 squared and 216 is 6 cubed. Okay. And here it is up there. Yeah. Okay. So we see that I can now rewrite 216 as what? 6 to the third. Yeah. See where I got that? This is the foundation of doing these problems. Okay. And I'm going to write 36 as what? Yeah, Zoomers, what am I going to write 36 as? Because I want the same base. Anyone, Zoomers? 36 is 6 squared. So then I write if the bases are the same, then the exponents are the same. And that might be a question in a Canvas quiz. According to the review session, if the bases are the same, then the exponents are the same. Okay, so now, poof, I can make the bases disappear because if the bases are the same, then the exponents are the same. So the bases disappear and I get 3r plus 2 is equal to how much? 36? Not 36. Everyone see that it's 2? Because if the bases are the same, then the exponents are the same. Notice we're going to have to distribute that, right? Don't forget those parentheses. Okay. So step one, if the bases are the same, then the exponents are the same. Step two, solve. I can either distribute or divide both sides by 3. Do I want to divide both sides by 3? Nah, I get a fraction. Distribute. So 3r plus 6 is equal to 2 minus 6. 3r is equal to, what is 2 minus 6? Yeah, -4 divided by 3. R is equal to -4/3. Okay, and what is the key to understanding these problems? If the bases are the same, then the exponents are the same. Yeah? If the, everyone say bases. If the bases are the same, then the, everyone say exponents. Exponents are the same. All right. So that's the key. Yeah, not too bad. Okay. Number 2. Colton's joining. Bye-bye. Have a good day. And he's like, you're just on number 2. I'm so late and you're just on number 2. Okay. So we go to the chart of powers that is on the back of the table of powers that's on the back of the chart of factors. And we see this line. Okay. So 25 can be written as what? 5 squared. Yeah, are we good with that? This is 5 squared. Okay, and 125 can be written as what, Zoomers? Five to what power, Zoomers? All right, third power. So we're gonna rewrite, rewrite with same base. Rewrite with the same base. Okay, so 25, I rewrite as 5 squared. And 125, I rewrite as 5. Yeah, to the third power. Okay, and then we say, if the bases are the same, then the exponents are the same. Okay, if the bases are the same, then the exponents are the same. So my next statement is the exponents are the same, right? That statement just said the exponents are the same. So what it looks like is, it looks like magic, poof, the bases disappear. Because if the bases are the same, then the exponents are the same. Probably getting tired of me saying that over and over. Okay, let's solve. What's my next step? Distribute. So 4x plus 2 is equal to negative 6x plus 3. Distribute. Now we are isolating. Okay, who should I move? Which x's? Now, am I going to add those x's together or do the opposite to move it? They must have been on the same side of the equal sign. That's only because, okay, let's decide. Sometimes we add and sometimes we subtract or add or subtract from both sides. Notice they are not together. They are on opposite sides of the equal sign, so we cannot combine like terms. So I am going to do the opposite to isolate. So 10x plus 2 is equal to 3. Hey, how are you? Good to see you. Ding, ding, ding. Thank you. Subtract 2. 10x is equal to 1. Divide by 10. X is equal to 1/10. This is the key right here. If the bases are the same, then the exponents are the same. Okay, we spent a lot of time on that. How could we solve this equation? Is this an exponential or a power equation? Uh-huh. This is a power equation, right? I know the exponent. So basically, I want to do the opposite of power is the root, but okay. The 2/3 root? No. There's an easier way. Okay. So instead of the 2/3 root, I'm going to raise it to what power? How can I get rid of 2/3? Okay, 3/2. Right? Because I multiply those right there. Okay, multiply, and we get x. Now, I could show you intuitively how to do this, and it's really cool. But you're not going to like it. So instead, we're going to go 25 with their calculator. Exponent 3 halves. But I will kind of show you. 25 to the 3 halves. The bottom of the fraction is the root. So that's a 5, right? The top of the fraction is the power. 5 cubed is, okay, so when I plug this into the calculator, I should get 125. Yeah, 25 to the exponent, 3 halves is 125. Okay, so you'll need to know how to do that on my calculators. Number 5. Now, just want to draw your attention. You know, I have a lot of people skipping the notes just because I excuse them at the end of the week. You can do well in this class without doing the notes, but look how helpful they are. So a little commercial for notes. Okay, they're actually helpful. Yeah, it is super helpful to do the notes on Monday and then review session on Tuesday. Okay, they actually go together in case I've never mentioned that. Okay, or you could just procrastinate and do everything next week. No, I'm just kidding. Don't do that. Okay, this is a table, but I can't do a table on my little thing. Okay. F of X. We're still getting used to this new language. Okay. Only one of these is the variable. Which one is the variable? The F or the X? Okay, so the X is the variable. F is not a variable, right? F is the function name. X is the variable. So X is the thing that we're going to plug in for. And F is just the function name. Okay. So I want this crazy thing. So first of all, how would I say that? So this is G of F of 3. That's how you say it. G of F of 3. Yeah? Okay. So start with the inside. F of 3. So I want you to take a guess. Everybody's guessing. I'll give you a hint. It's a number between -1 and 12. So everybody's guessing. What is F of 3? Okay, we have one guess. Everybody guesses. If you're in my room, everybody guesses. I'm just kidding. You can do your work. Okay, I have a couple guesses. Anyone else want to guess? Oh, I have more. Wow, I'm getting a lot of the same guess. A lot of people are guessing. Now, do you realize how good for your brain it is to guess? Your brain is like synapses firing when you guess. Okay, so I need to go. Am I going to the F box or the G box? I'm going to the F box, right? And I want F of 3 right there. No, yeah, I start at the top. So when X is 3, F of 3 is 2. So I take out F of 3 and I replace it with 2. Okay, so now G of 2, final answer. G of 2 is 4. So I go to the G box. G of 2 is 4. Yeah, final answer 4. Okay, so it's like learning to speak a new language. The math is not that bad. It's just the notation that's crazy. So how about F of G of 3 is the same as F of what? Not the final answer. What's going to go in here? F of G of 3. I take out G of 3 and I replace it with what, Zoomers? Ding, ding, ding. Anyone else? Can we see that G of 3 is right there? So G of 3 is 6. And I can't erase that. Okay, so G of 3 is 6. So I'm not done. Now I need F of 6. So final answer is, yeah, 5. Okay, now if you want to see someone else do a similar problem, you can look at the videos, the notes. All right. Or if that's confusing, we can talk about it at the end. Okay, number 6. All right, equations, not tables. Okay, so G of H of -2. G of H of -2. So over here in my scratch paper, the first thing I need to calculate is the inside. Yeah. That one right there. Okay, so what do I need to plug into that? So h of -2 is 4 times -2 minus 1. Yeah. Which is -8 minus 1, which is -9. So I'm going to take out h of -2 and replace it with -9. Yeah? Everyone see what we just did? Okay. So now I want g of -9. So how can I do g of -9? X squared minus 5, yeah? So I take -9 and I plug it into g. So g of -9 is -9 parentheses. Whenever I plug in a negative number, put it in parentheses, please. Otherwise, you're going to get it wrong. And if you plug that into your calculator with no parentheses, you're going to get it wrong. Okay, let's practice. Calculator. Parentheses. You're like 81 minus 5. I can do that. But anyway, parentheses, -9, close your parentheses, squared minus 5. Yeah, is 76. Final answer, 76. Plug it into the inner one and then plug it in to plug the answer into the outer one. Okay, that is the new material for the week. Now we are going through and reviewing. Okay, so what's our priorities? Where do you want to start? Requests? Or are you guys good? You can do all of these on your own. This one?
Oh yeah, I thought it was
Yeah.
I think number 1.
Okay. We're going to do 1 and 2. Notice when you take your test, you're going to make a table of values for each one. Okay. Okay. Now let's talk about the parent. Okay. So what does this graph look like? Okay. So this is an airplane taking off as seen from left to right. No, no, it's not. Duh. I'm sorry. Woo. Okay. If the base of the exponential is a fraction, this is not an airplane taking off. This is an airplane coming in for a landing. I'm so sorry.
Oh, so it's like the opposite.
Yeah, because of the fraction, it's getting smaller. I'm sorry. Okay. This one, because the base of the exponential is a whole number, this is an airplane taking off. Okay. So we're going to have -1, 0, and 1. And then occasionally, if we want to be a little more accurate, we could also plug in 2. Right, Brianna? Sometimes we need to plug in too.
I'm not confused on that one.
Okay. So we're going to plug in -1. What does a negative exponent do to a fraction? I don't know. Let's just plug it into the calculator and find out. 4 times parentheses 1/2 to the -1. Anyone have a guess what this is going to be?
8.
Ding, ding, ding. 8. What did that -1 do? It flipped it, right? Cross the line, change the sign. Okay. So -1 is 8. 0. Okay. So this is always 1, right? So this becomes 4 times 1 is 4. Oh, look, it starts at 4. The y-intercept is 4, right? Well, that's interesting. And what's happening?
It decreases.
By it's getting cut in. I don't know. So let's do another one. 4 times 1/2 to the 1. What are we going to get? Two. Okay, so my y value is getting cut in half. Oh, look, cut in half. See the multiplier? Cut in half. This is kind of like I start off with 8 M&Ms. I shake the box and I eat the ones where the M is up. Probably a half, right? Shake the box again, eat the ones. So this is an exponential function. It is decreasing exponentially. It's a half. So when this is 2, this is 1. You only have to do a table that has 3 values, but sometimes we like to do 4 values. -1 is 8, 0 is 4, 1 is 2, and 2 is 1. That 4th value kind of helps with the shape. So there's number 1. Okay, any other requests? You guys are doing all of these as your last practice before taking the exam. Requests?
Four.
Okay. Parent. What is it going to look like?
2.
Exponent of 2 makes, what is it going to look like, Zoomers? Exponent of 2 makes a U. This is a happy U because A is a positive number. So we're just going to put A equals 3. Positive number, happy U. Okay. Zoomers, what's the next thing I need to find? Vertex. All right, thank you. The vertex is -3, +4. Okay. Oh, this is annoying. Oh, super annoying.
We
Some-
all the test too.
Sometimes that happens. Okay. Now, let's make a table. So, table of 3 ordered pairs. The vertex goes in the middle. So I catch the most important part of the parabola. So -3, 4. 1 to the left is -2. 1 to the right is -4. And this is actually right, and this is actually left. I did that wrong, but doesn't matter. Okay, does anyone have a guess what that's going to be? You can either calculate it or you can use your knowledge of A. Okay, let's calculate it. 3 times -2 plus 3 squared plus 4. Oh, it's 7, which is 3 above the vertex. Oh, so if A is 3, these are going to be 3 above the vertex. Isn't that nice? Don't you love these problems? So over 1, 1, 2, 3. Annoying. Sorry. Over 1, 1, 2, 3. Sorry for the annoying graph. Yeah, parent graph, vertex, table, and A will help you with the table. Okay, requests, or you just want to do the rest on your own? Okay. Parent graph. This is a U, but what's different about this U? A is -2. It is an upside down U or a sad U because A is negative. There we go. Thank you. Next up, vertex. +1, +2. Yeah, +1, +2. Opposite of the X, same for the Y. Okay, let's make a table of values. The vertex goes in the middle. I could plug 1 in and surprise, I would get 2. So 1, 2. Uh-oh. Is this graph gonna fit? It looks like I'm gonna go off the graph. Am I gonna go off the graph? No, because it's an upside down U. So it's gonna fit perfectly. Okay, in your table, 1 to the left, 1 to the right. I wonder how A is going to affect my graph. It's going to be interesting. Okay, so let's plug in 0. -2 times 0 minus 1 squared plus 2. -2 times 1. Oh, careful. Let's talk about this. Okay. Are those negatives gonna cancel? Please excuse. I'm so glad you brought this up, my dear Aunt Sally. Now, canceling these would be in what level? Way down here, right? So before I try to cancel, what am I going to do first? Multiply what? Exponent, right? You're going to do the exponent first. So what is -1 squared? That's -1 times itself. That becomes +1. Why does the negative not cancel? Because you have to do the exponent before, actually, the exponent before multiplying. So then we get -2 + 2 = 0. Now, if I would have gotten 4, it wouldn't be sad you, right? So 0 is 0. And what do you think 2 is? 0. Or we took A, we were at 2, we went down 2 and we got 0. See how you could see A in the table? You could also see A in the graph. Just in case on the test, you're given a graph and you have to tell me what A is. Okay. Let's do number 11. Okay, so my hours today on the schedule, it says no afternoon hours. I have to take my daughter to a doctor's appointment from 1 to 2, and then I'm coming back. So I'll be here from I said no afternoon hours, but I'll be here from 2 to 3:15. Okay, I'll maybe earlier than 2, but definitely, unless the doctor appointment goes super long, I'll be here by 2. Okay. Got it. All right. So first, parent. Okay, this is weird that this is an inequality to solve and it has a parent because I will be graphing. Okay, so this is what you say. Less is nest. More is oars. Less is nest. Okay, time to see me. Okay, and this has video too. You ready? Less is nest, more is oar. Less is nest, more is oar. Yeah, oars, nest. Okay, bye. Okay, so the parent graph, what is this going to look like? A nest or oars? Oh, sorry. Step 0, isolate your absolute value. There's nothing to move, right? So then we see that greater than or equal to is oars. Less is nest, more is oar. So it's going to have filled in dots and it's going to go out. Yeah. Super important, because what if I give you a problem like this? Could you tell me what the graph looked like? Yep. More is or. Yeah. Okay. So that's our parent graph. Now, what's the next step? Okay, we're gonna isolate. Notice, can I add 8? Not yet, because it's inside the absolute value. So the next step is split. So I have -8 minus 5a greater than or equal to 12. And I have the opposite of that. Are we good? Are you with me? Okay. So let's take the left one, add 8 to both sides. -5a greater than or equal to 20. Divide by -5. Oh, wow. I usually don't divide on the first one. A is, okay, got a -4 over here. A is less than or equal to -4, right? Whenever you multiply or divide by a negative, flip the sign. Now, look at this one. I usually divide the negative to make it go away, but I'm not going to. Why am I going to distribute that negative? Yeah, then they'll all become positive, right? So I'm going to distribute. That's really an invisible one. So distribute that negative. Okay, isolate, subtract 8. And divide by 5. Okay. So now I'm going to say A, please. We might be done. Oh, look, there it is. Okay. A less than or equal to -4, or A greater than or equal to 4/5. And the graph looks like ors. So less than or equal to -4. Or greater than or equal to 4/5. Well, 4/5 is a little less than 1, right? So to do this, you can either talk about the fact that greater than is a union. So some teachers will talk about the fact that this is the union, but I like to say less is nest, more is or. Less is nest, more is or. Okay, but the videos will probably use the word union in there. Okay, you are on your own to do these. Any other requests?
I did it, but I got my grade on.
Okay, number 2. Let's make a table. Oh, the parent graph should be an airplane taking off. So 3 times 2 to the -1, That's going to flip it to the bottom, 3/2, 1.5. Yeah, or use a calculator. 3 times 2 to the 0th. Anything to the 0th power is 1. 3 times 1 is 3. 3 times 2 to the 1st is what, Zoomers? Six. Notice the y-intercept is 3 and we are doubling. Okay, so -1 is 1.5. 0 is 3. 1 is 6. 2 is 12. So with exponentials, sometimes it's nice to make a table of 4 values. Okay, any other requests? Or you're good on doing these on your own? Okay, number 8. Parent graph. Absolute value makes? Yep. Absolute value makes a V. Notice the parabola x squared has a curved bottom and the absolute value is a V. It comes to a point. And I notice that A equals 2, which is funny. Everything's a 2 in here, but it's that front coefficient. Vertex. I actually don't like this one because everything's a 2. +2, +2. Okay. Let's make a table. 2, 2 is going to go in the middle of the table. 1 to the left is 1, 1 to the right is 3. So we're going to plug in so what is that going to be? You know what? I get confused, so I'm not going to do it. I'm going to use the value of A. What does the value of A? Because you know what? I have a high possibility of getting an arithmetic error doing that absolute value problem. Okay, so instead, I'm going to use A. So what does A tell us about this value right here? It's 4. Yeah, do you see where we got the 4? So A is 2, 1 to the right, up 2. 1 to the left, up 2. That is the stretch factor. This one looks like my little reindeer. So I take 2 and I add 2 to get 1 to the left and 1 to the right. Now, which makes sense because 2 absolute value of -1 is 1 plus 2 is 4. So it does make sense. But with these absolute value, you have a higher possibility of making an arithmetic error because you can't plug absolute value into your calculator.
Yeah, I was missing that. I was so confused.
Okay, so you either do it in your head or you use the value of A to help you use the other method for getting those two values. Any questions on where I got the 4? Yeah, see how we used A? If A was -2, you would subtract 2, you would go down. Okay, any other requests? All right, number 8. Okay, if we talk about the parent, the absolute value equation is expecting 2 answers. Okay, first step, isolate the absolute value. Subtract 3 from both sides. -52. Okay, here's the hardest part right here. What is the next step? I'm sorry, what? Yes. Ding, ding, ding. So is different. Okay. Divide by -4. So I have absolute value of 5 plus 4p is equal to -13, +13. Okay, +13. Okay. Sorry, that was probably really loud in the mic. So I isolated my absolute value. Okay, what's the next step? Nope. Before I subtract 5. Okay, split. Five plus 4p is equal to 13. And the negative of 5 plus 4p is equal to 13. Okay, now we're going to solve. 4p is equal to 8 divided by 4. P is equal to 2. Okay, I could either distribute the negative or divide both sides by -1. Let's divide both sides by -1. 5 plus 4p is equal to -13. Minus 5. 4p is equal to -18. Divide by 4. P is equal to. Now I'm going to use my calculator to reduce 18 ABC 4. Oops, I got a mixed number. Second ABC equals. All right, -9/2. Okay, so P is equal to 2 and -9/2. 2 answers. Absolute value, you should always get the 2 answers. Sometimes this quadratic, sometimes you get the same answer, but okay. Everything else on your own, unless you have more requests. Any more requests? Are you good? Okay.
7.
7. Parent graph. This is a sleeping U cut in half. A half sleeping U. Vertex. -6, -3. Table. So -6, -3. To the left is -7. To the right is -5. And I'm going to do a fourth value. -4.
For this one, could you do arithmetic and soup?
A. Yeah. It's a little trickier because of the square root, but yes. And you know what? -4 is not really going to help me. Anyway, let's plug in -7, but yes, we could actually do A. Just don't do it left and right. -7 + 6 - 3. Okay, what do you get when you try to take, oh wait, let's just do it. -7 + 6 is -1. What do you get when you try to take the square root of -1?
You cancel.
Error. Not a real number, it's imaginary. Okay, let's do -5. Is 3 times the square root of 1, which is 3 times 1 is 3, which is 0. So -6, -3. And then -5 is 0. Do you see A? Yeah, it works. And -4, nah, it's gonna give me a decimal anyway. I'm good. I have 2 points. If I really wanted another one, I could do um 3, no, -2. I could do -2. That would be 3 square root +4, which is 2, which is 6 - 3, which is 3. -2 should be 3. So it's actually climbing pretty quickly. But what I'm looking at is right here, those first 2 points. You don't have to do an extra point. Okay. Everything else on your own. I believe I did all of them in last year's video. So if you get stuck, look at last year's video. Okay, that is it for today. Yeah, make plans. You are welcome. Make plans